So hey guys, welcome back again to my YouTube channel. So for today's video, I will do a chapter 6 summary, which is network layer. So we have a 6.1 is network layer protocol, 6.2 is routing, 6.3 is routers, and 6.4 is configure is Cisco router. So network layer protocol. So we have here the network layer, the exchange of data. Network layer, which resides at OSI layer 3, provides services that allows end device to exchange data across the network. So as you can see, it is changing data. So we have addressing of a device, encapsulation, routing, and decapsulation. So addressing IP address must be unique for identification purposes. For encapsulation, the protocol data units from the transport layer are encapsulated. Routing, the network layer provides services to direct packets to other networks. So decapsulation, the destination host decapsulate the packets. So for the network, we have Internet Protocol version 4 and Internet Protocol version 6, which is commonly used, or for the shortcut is IPv4 and IPv6. For encapsulating IP, a network layer IP encapsulates the transport layer segment by adding an IP header for the purpose of delivery to the destination host. So, characteristic of IP was designed as protocol with low overhead. It provides only the function required to deliver a packet from the source to a destination. So we have a IP connectionless. IP is connectionless protocol, not dedicated end-to-end connection is created before data is sent. So as you can see, we have a letter, we have mailbox. So the vehicle will send a letter for the destination. So the sender doesn't know if the receiver is present, if the letter is arrived, if the receiver can read the letter, and the receiver doesn't know when it's coming. So IP best for effort delivery. IP is considered unreliable because it does not guarantee that all packets that are sent will be received. So, in shortly, it can not consider if you have sent, for example, if you have a letter, you will create a letter and you will give to the for you will give the letter for your friend. So your friend did not know if it is coming or it will be received. So media independent, so operates independently from the media that carries the data at lower layer of the protocol stack. It does not care if the media is copper cable or fiber optic or wireless. So we have a types of media, which is copper cable, fiber optic, and wireless. So if the media is independent, so it cannot be doesn't care of this media. So IPv4 packet header consists of field containing binary numbers. These numbers identify various settings of IP packet, which are examined by the layer 3 process. So introducing IPv6, how many addresses are available in IPv6? So increase address space based on 128-bit addressing versus 32-bit with IPv4. Let's include that. So we have routing. So fast host forwarding decision. So we have a host can ping itself for testing purposes using 127.0.0.1, which is referred as loopback interface. So local host is host, same local network As the sending host, the hosts share the same network addresses. So we have a default gateway, routes traffic to other networks, local IP in the same address range as the other hosts and the network. So as you can see, we have here the using the default gateway. So for example, this PC1 has an IP of the local network route of this scenario is 192.168.10.0/24. So it means the default gateway oh, the default gateway of this network is 192.168.10.1, and then the IP address of the PC1 is 192.168.10.2, and then the PC2 IP address is 10.3. So understanding remote route and entries. So 10.1.1/24 identify the destination network here. So 90 is administrative distance, and 217.0.122.112 represent the metric or value assigned. So the next hop or IP address is the next router, and route time stop identifies the when the router was last. So serial outgoing interface. So routers is a computer like computers. A router requires a CPU, an operating system, and memory. Cisco routers are designed to meet the needs of wide variety of business. So we have a branch, teleworkers, small business, and medium-sized branch sites. One large business organization and enterprise service provider, large service providers. So router CPU, OS, and OS. So like computers, Cisco routers require a CPU to execute OS instruction, including system, installation, routing functions, and switching. So here's the router CPU in the figure. So configure a Cisco router. First, basic switch configuration. So as you can see here, it is the basic switch configuration step. So first we have enable, configure terminal, hostname S1. So enable secret class for the secret for the password. In line console we have password Cisco and login, line VTY015 because it has a 16 ports of the switch, and then so on. So we have here path tracer. So configure root router interface. For routers to be reachable by other devices in the network, and the band interface must be configured. For the example, Cisco 1941 router has 4 in-band interface. We have 2 gigabit interface, which is G0/0 and G0/1. One serial 1 interface with 2 and serial 0/0/0 and serial 0/0/1. So it is important that use the command line shutdown when they already make the interface active. So we have show IP interface brief, show IP root, and show IP interface. So default gateway, it's easy. IP default, packet. So for the summary, build a switch building a switch, it is lab, and then processing integration. So this is my end of my summary on chapter, which chapter? Chapter 6, and I hope you enjoy it, and thank you for watching. Bye.